Hi, welcome to episode 3 of the Moisture, Clouds, and Precipitation series. In this video, we will talk about the lifting mechanisms of air, or simply, processes that lift air. To get an overview, we will discover orographic lifting, convective lifting, frontal wedging, and convergence lifting. Let's start with orographic lifting. For orographic lifting to occur, we need a key ingredient. We need a mountain. Imagine that this is a mountain. When the prevailing winds, which are warm and moist, faces a topographical barrier like a mountain, it has no choice but to go up. It cannot go through or go down because of the barrier. And once the warm moist air reaches a certain altitude, it begins to cool. And if there is enough moisture in the air and there are condensation nuclei on the atmosphere, it will begin to form clouds. And if there is enough moisture in the clouds and the water droplets become so heavy, it will begin to precipitate. It can either be rain or snow depending on the temperature of the atmosphere. And the air will continue to move towards the other side of the mountain, which is dry and barren and cannot grow trees and vegetation properly. This is called the leeward side of the mountain. This is called the leeward side. And this side of the mountain with enough precipitation and enough vegetation is called the windward side. Next up is convective lifting. This lifting mechanism is the most common because it has an ingredient accessible to almost anything on Earth's surface, the sun's heat. Let me draw here a representation of the sun. When the sun heats a particular part of Earth's surface, which could be either a water or land surface, but in this case, it will be a land surface, some of the sun's heat is reflected back into the atmosphere. This is the sun's heat, and some are reflected back into the atmosphere. Some of the heat will be transferred to the air moving over the land through convection, and this warm air tends to rise. As the warm air loses its density, it rises and rises higher up in the atmosphere. To balance this out, cold air will replace the lost warm air, and the cycle repeats. Another lifting mechanism of air is called frontal wedging. It happens when a cold air mass, this is a cold air mass, meets a warm air mass. And since cold air mass is denser than warm air mass, it tends to wedge underneath. The warm air, and warm air is pushed up high in the atmosphere. And as it is moved up high in the atmosphere, it will begin to cool. Once there is enough moisture on the air, it will begin to form clouds. And if there is enough moisture in the clouds, it will begin to precipitate or to rain. Convergence lifting happens when two air masses collide or converge in a specific area. In this case, two cold air masses converge and meet over a specific area. Convergence lifting is different from frontal wedging. In convergence lifting, there is no need for warm or cold air masses, and in our case, we used cold air masses. Hence, the densities of the colliding air are about the same. Because of this, there will be no air that will wedge underneath or go up. In this case, both will go up. Both will go up and create an updraft. This creates a low pressure area. An LPA, that is the precursor to typhoons, hurricanes, and even cyclones. To recap, we have four processes that lift air. We have orographic lifting, convective lifting, frontal wedging, and convergence lifting. In orographic lifting, it requires a mountain. Convective lifting is dependent on the sun's heat. Frontal wedging is a war between a cold front and a warm front. And convergence lifting is when we get low pressure areas that can develop into dangerous storms. That's all for this video. See you again next time.